Hi everyone. So today we'll be continuing with the problems of Thomas Hungerford's book Into Abstract Algebra. So number 8 says the following: use the division algorithm to prove that every odd integer is either of the form 4k plus 1 or of the form 4k plus 3 for some integer k. So let n be an odd integer, divide n by 4 to get a quotient as well as a remainder. So then we have that n is 4 times some quotient k plus r, where r is guaranteed to be bigger than or equal to 0 and less than 4. So we can write the n differently as 2 multiplied by 2k plus r. Here we know that n is odd, so we cannot really have r is 0 or 2, because then that would give that n is even. So then the choices that were left out with is r is equal to 1 or 3, and we get the solution to the problem. So the next problem says that proves that if you have a cube, then it has a form of 3 specific forms only. So let's see how we can show that. So first of all, let n be a fixed integer. Then divide n by 3 to get a corresponding quotient as well as a remainder. So 3 times q plus r, where r is between 0 and less than 3. And then if we cube n, then that is the same thing as cubing 3q plus r to the power of 3, which is 3q plus r squared multiplied by 3q plus r. So then if we expand the squared, we get that 3 multiplied by 3q squared plus 3 multiplied by q r plus 3 multiplied by qr plus r squared times 3q plus r. Then that would be 9q squared plus 2 times 3. Let me put the 3 as the first term. 3 times 2 times qr plus r squared times 3q plus r. Then what we're left out with is the following. So we get 9 multiplied by 3q to the power of 3 plus 9 multiplied by 2 multiplied by qr plus 3 times q times r squared. And here we have plus, let's see, so r times 9q squared, and then you have 3 multiplied by 2 qr squared plus r to the power of 3. So we add the like terms, but I want to keep 9 factored out. So let's factor it out more. So 3 times q to the power of 3 plus 9 multiplied by 2qr plus 3q r squared plus 6qr squared, then that is 9qr squared plus 9q squared r plus r power 3. So let's factor 9 out. So we have 3q to the power of 3 plus 2qr plus qr squared plus q squared r plus r power 3. So that is 9. We call that term that I will highlight in red k. And we have r power 3. So r has specific choices. You can also invoke the binomial theorem. So what are the choices for r? So the choices for r, it's either 0, 1, or 2. So if r is equal to 2, then you have n power 3 is 9k plus 8. If r is equal to 1, then we have n power 3 is 9k plus 1. And finally, if r is equal to 0, we get n power 3 is 9k. And we get the forms that we wanted. Alright, thank you everyone, and I will see you in the next video. Thank you, bye.